All right, last one. The last video that was 7.1, the very beginning of area between two curves. That was pretty easy. Again, you're taking top minus the bottom. In this case, this is part 2 of it, where we're going to find the area between two curves as well, but the curves might not be nice as top minus the bottom anyway. So to review, to find the area between two curves, you always write the integral as the upper minus the lower, right? I got to go to draw. Upper minus lower, or f of x minus g of x, depending upon which one's top or bottom. Some pairs of functions intersect at more than one point, though. Therefore, as a result, the function that we would consider the upper function can switch and become the lower function. And therefore, you have to split the integrals. Okay, so what I mean by that is this. So here we can obviously see that we have a cubic function, 3x minus x squared minus 10x. And then we have a parabola, negative x squared plus 2x. And the cubic function, okay, it goes up, comes back down, and then goes back up. And then it's going to go up forever and then go back down forever. Whereas the parabola, the blue graph there, is upside down parabola, and that's obviously just going to keep going and never pop back up, right? It's a parabola. So we can see 3 points of intersection. And on the graph here, it's pretty nice because the 3 points of intersection are already labeled. It's at -2, right, at 0, and then at +2. So that's very easy to do that. In some cases, you might actually have to find the points of intersection, and it's just got to set them equal to each other and solve. Okay, just kind of do that. This one, if we did that, so let's do that real quick. 3x to the third. I'm not sure if it's going to work out pretty nice. It should, though. Minus x squared minus 10x equals negative x squared plus 2x. So this is 3x to the third. I'm going to bring that over. That's going to cancel. I'm going to bring this over. That's negative 12x equals 0. I factor out a 3x. I get x squared minus 4 equals 0. So this is 0, and this is plus minus 2. So it does work out pretty nice to factor it out. So those are my three values. And in this case, what I'm going to do is I'm going to start from the left and work my way to the right. So from the left, I'm going to get from -2 to 0. The top function is going to be that cubic function. So it's 3x to the third minus x squared minus 10x minus, now it's the square to parabola, so minus negative x squared plus 2x. And that is dx, right? But then from 0 to 2, okay, I have to add in that other integral because I want to find this area here, and I want to find all of this area in there. And so I got to add in that second integral from 0 to 2 of, now the top function is my parabola, so negative x squared plus 2x minus, okay, 3x to the third minus x squared minus 10x, and all of this is again dx. Okay, and then I'm just gonna like maybe simplify them real quick. This is from -2 to 0. Okay, 3x to the third is definitely going to stay there. Minus x squared plus, those are going to cancel, right? And then minus 12x. So we technically already found that out, right? Dx plus the integral from 0 to 2. I got negative x to the, so that's going to cancel as well. This is now going to be a negative 3x to the third. And then a plus 12x, okay, plus 12x dx. You can definitely integrate that. I'm not going to spend the time to do that. If you can't do that by now, that's not a very good thing, okay. Equals, and so the value that you're going to end up getting is, I got to unlock my phone here, is 24. Okay, you're going to get a nice number of 24. All right, that is the area, yeah. Oh, it's late at night. That's the area right here between those two curves. That's why you have to split that integral. So let's go on like Donkey Kong. If a function is written in terms of y, it's most often more convenient to represent the area as an integral with respect to y. If that's the case, instead of upper minus lower, you are going to have right minus left. The reason we do right minus left, okay, and this is what I'm saying. So f of y, instead of it being f of x equals something, it's f of y equals 3 minus y squared. And then this is y plus 1. Instead of, with the x value, so you're finding them dx, we are taking the area with respect to the x-axis. Okay, so you're finding this area here. So that's why I'm doing top minus bottom. But when I'm doing right minus left, I'm finding the area with respect to the y-axis, okay, the y-axis, and that's what I'm doing there. So that's basically, well, if you remember last year we talked about vertical rectangles versus horizontal rectangles, and if you didn't do Unit 11, you probably have no idea what I'm just talking about. Even if you did, you probably have no idea what I'm talking about. But that's basically what we're doing. And so let's try and figure this out. Well, these two pieces intersect at the y value of 1 and the y value of -2. Not the x, because I'm taking the variable, I'm taking the antiderivative with respect to y. So the integral is going to be from -2 to +1. All right? Now, what's the top function? Well, the top function is the rightmost function. I'm finding the area in between this curve in here. That's what I'm doing. And so the rightmost is that parabola, so that's 3 minus y squared minus y plus 1 dy. And you're going to differentiate it the same, or anti-differentiate it the same exact way. And so you're going to get -2 to 1 of, looks to be, let's see, negative y squared minus y plus 2 dy. When you integrate this, okay, again, you're going to get negative y to the 3 over 3 minus y squared over 2 plus 2y from -2 to 1. Okay, it's pretty simple. And then what you are going to do is just, I guess, plug it in like normal, right? You're going to get 4.5. Okay, 4.5. Now, if you wanted, so I'm going to go ahead and delete all of this garbage here. If you wanted to kind of, let's see if I can do this. Nope, can't do this nicely. Nope, can't do that nicely, can I? Nope, 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 nope. Nicely? Nope. Eraser. There we go. Not really nice, but anyway. If you wanted to, like, say, you know what, I don't like y's, I hate y's, I don't see the benefit of y's, and you wanted to put this in terms of x, then this is really x equals 3 minus y squared, and you could solve this. So this is x minus 3 divided by the negative, right? So it's negative there, and then you could square root that, and I mean that doesn't really help you at all, but that's what you can do. And this would be the same. This would be x equals y plus 1, so y is equal to x minus 1, and that's really what your graph is right there, x minus 1. But if you do it this way, okay, if you do it this way, there's technically two parts to this. There's a plus and a minus to the square root there, and so you might have a harder time figuring out that you got to take both sides of it. And so I don't recommend doing that because it's just not a very good way of doing it. Because in this case, you're going to have to split the integral. You'd have to go from here to here, and then you'd have to go from here to here. And I do not recommend doing that. But if you want to, you're more than welcome to do that. I can show you if you really want to do that, but I'm not going to show you in this video. Okay? That's it, I guess. That's it. We're done. We are done. All right, deuces. I'll see you in the next one.